An object rotates through a specific axis. In the previous series, we were familiar with the term moment of inertia, which is nothing but a measure of an object's ability to maintain its angular velocity. This quantity is often symbolized as big I. I is for inertia. The moment of inertia is proportional to the mass of the object. The moment of inertia is proportional to the radius of the object relative to the axis. Mathematically, the moment of inertia can be calculated through the equation I equals mr squared. This equation is valid for point particles, an object that has mass but no size. To understand this equation further, in a three-dimensional Cartesian coordinate system, there are point particles with coordinates r sub x, r sub y, r sub z, where the r sub z value is 0. We will calculate the value of the moment of inertia about three axes, the x-axis, y-axis, and z-axis. So, we will duplicate this system into three. In the first system, the particles will rotate about the x-axis. This means that the axis is the x-axis. We should be able to imagine this particle rotating about the x-axis. Even though the intersection point on the x-axis is r sub x, the distance from the point to the axis is r sub y. Thus, the value of the moment of inertia on the x-axis, I sub x, is equal to mr sub x squared. In the second system, the particles will rotate about the y-axis. This means the axis is the y-axis. Now the distance of the point to the axis is r sub x. Thus, the value of the moment of inertia on the y-axis, I sub y, is equal to mr sub y squared. In the third system, the particles will rotate about the z-axis. This means that the axis is the z-axis. The distance from the point to the axis is the length of the line perpendicular to the axis leading to the point particle. Using the Pythagorean theorem, the length of this line is the root of r sub x squared plus r sub y squared. Thus, the value of the moment of inertia on the z-axis, I sub z, is equal to m multiplied by r sub x squared plus r sub y squared. From here, we can see that the same particle can have several values of moment of inertia depending on its axis. Thank you for watching this video. And don't forget to watch the next video.